So in this section, we're going to learn how to use matrices to solve systems of linear equations. If the equation is not linear, you may not use the matrices using Kramer's rule. You'll have to go back to substitution or elimination or graphing method to solve. So we're going to solve for 2 equations, 2 variables, and 3 equations, 3 variables using this method for matrices. You can actually use this for a 4x4, a 10x10, a 30x30. It's just a little bit more evolved way to do it. So what we're going to do is we're going to eventually learn how to find determinants first, and then we're going to solve systems using Kramer's rule. So let's talk about the determinant of a 2x2 matrix. This is the key type of skill we're going to need to do every single problem in this section. The 2x2 determinant is often something they will test on an ACT. So this is something you should be familiar with and be able to handle for those of you that still have to take your ACT next year or the year after. All right, so let's say you're given a matrix A, and again, we're going to read row by row. So A, B, C, D. So this is 2 rows with 2 columns. So this is what we call a square matrix. Okay, we can only find the determinants of a square matrix. So we're going to deal with 2 rows, 2 columns in this one. So what we do is we multiply what we call the main diagonal. We start at element 1, 1, and then the main diagonal, everything in here, its row position and column position are the same. So first row, first column, second row, second column, third row, third column, and so on and so on. Okay. So what we do is we multiply the numbers, these 2 numbers in the main diagonal, AD, and then we subtract when we go backwards. We're going to multiply in the other diagonal, BC. There's 2 sets of notations that they can tell you that they're going to use, or they're expecting you to find the determinant of a matrix. And they could tell you verbally, just write out, find the determinant of A, and then give you A as a matrix. Or they can say, find the determinant using this notation, DET, A. Or if you notice, this one here, it doesn't have the brackets. It looks like absolute value bars instead of a matrix. So when you see a matrix inside of absolute value bars, that means you're going to find the determinant. Again, it's really simple. Take A times D minus B times C. So let's go find the determinant of A. We expect to see work on this. I would not do any calculations for my work. I would just tell you what I'm doing. So if you write this down, you'll get everything but maybe 1 point for the final answer, because you're telling me exactly how to calculate it. Now, if you mess up your calculations and you try to do 2 times -4 and you write +8 instead of -8, then you would start having some problems. So I will, if I see this work right here, we're good. Now, if you want to show this work as well, that is fine. If you want to only show the red work, that is fine, but you're risking your points if you make a calculation error. I have to grade what I see. So the blue work is perfectly, and that's all you need to have. The red work, as long as you calculate correctly, is all you need to have for work, and then you calculate, and we get 7. All right, so now that we know how to find the determinant of a 2x2, it's really easy. You multiply 2 numbers, then you subtract the product of 2 other numbers. We're going to talk about how to use that skill to solve a system of equations. Okay, so what we're going to do is we're going to rewrite our system as a matrix equation, and that is from our multiplication skills that we worked on in the last unit, or last section. And then we're going to set up 3 determinants, d, dx, dy. If you have a 3x3, then you're going to have to solve up a dz. So we have the overall determinant, and then you have a special one for your x, your y, and your z. Now, to find your x, y, and z, here is Kramer's rule. So if you're ever asked to state Kramer's rule, you'll state that x equals dx over d, y equals dy over d, z equals dz over d. That's the rule you would state. So we are going to use this rule to set this problem up. Now, we don't have a z, so we only have our d, dx, dy. The number of variables and the number of equations should be the same. And if you would take the number of variables or number of equations and add 1 to it, that's how many determinants you will need to set up to solve using Kramer's rule. The first thing I'm going to do is set up my matrix equation. So I'm going to put my coefficients first, then my variables, and then my constants. So my coefficients are 2, 3 for the first equation, -5, -4 for the second equation. So remember that first column is x, that second column is y. Well, if I'm multiplying a matrix to this 2 by 2, it's got to be a 2 by something. And the rows have to represent x for the first row and y for the second row. So we are going to put for our variable matrix, the thing we're looking for, x, y. All right, the last thing we're going to do is we're going to go put our constants over here. So a 2 by 2 times a 2 by 1 has to give you a 2 by 1. So we have 6, 8 here. Okay, so I'm just going to take a moment here to use a little smart magic. Just give me a moment to group this stuff together. And then give me a second here because I want you to be able to see where these are coming from. So I'm going to put a cloner on these here. Okay, so we're going to set up our D matrix. Our D matrix is just your coefficients. So we're going to write the determinant of the coefficient matrix. And we're going to have our dx and our dy. Okay, hold on. So what I'm going to do is I'm going to take the coefficient matrix and set it up for my D matrix here. And then in the dx, what I'm going to do is I'm going to copy the D matrix over there, except for I'm going to take the x column out and put the constants in their place. For the dy determinant, I'm going to put the constants in the y column. So I'm going to copy the x column and replace the y column with the constant. So when you're finding your dx, dy, dz, dw, whatever you have, the variable that you see right here, that's the column you replace with the constants. When I see the dx, I replace the x column. All right, now I'm going to go calculate all three determinants. So this one will be 2 times -4 minus 3 times -5. That's -8 plus 15 or 7. That was our very first example, by the way. So I'm getting the same answer. I'm happy. Then I have dx equals 6 times -4 minus 3 times 8. So we have -24 minus 24, so -48. And then our last piece is dy. So we got 2 times 8 minus 6 times -5. So 16 plus 30. So dy is 46. Now, don't forget what our goal is. Our goal is to solve the systems of equation. Our answer must be an ordered solution where we have an x value and a y value. So Kramer's rule says if you take these determinants and you take dx and you put d for denominator in the bottom, that gives you your x coordinate. All you have to do is reduce the fraction if possible. If not, leave it as an improper fraction. So then we have y, which is dy over d. That one doesn't reduce, so we're left with 46/7. A lot of people really like Kramer's rule. because you never have to deal with fractions. Calculations are pretty quick and easy. You don't have to find least common multiples. You have basically formaic way to solve your equations. Now, the proof for this I'm unable to do since we are kind of going out of order, but you would prove this using inverse matrix. Inverse matrix, something called Gauss-Jordan. But at this point in time, we can't do that at the moment. All right, so let's set this up using Kramer's rule. So once again, write your matrix equation. Constants times variable, coefficients times variables equal constants. And then we're going to set up our three determinants, t. So we're just going to copy dx. So let me go ahead and change the colors over here on this constant. So what we're going to do is we're going to put the constants in for the variable that's listed in that determinant. And then we're going to copy down the other variable. And for dy, the x's are still 3, 2, just like the D matrix. But now we're going to put 7, 4 in for our y column. Now, before I finish my calculations, if your D matrix is 0, that means you would be dividing by 0. So that tells you there's either no solution or infinite solution. There is a way to tell from Kramer's rule. If you get 0 over 0, that would be infinite many solutions. Because 0 divided by 0, the answer you're looking for is, what did I times by 0 to get 0? Well, it could be a whole bunch of things. If you get 5 over 0, that would be an example of no solution. I can never divide 5 by 0 and get an answer because I can never take 0 times a number to get 5. All right. If you get an infinite many, then you have to go back to these original equations and use your parametric form to find your answer or your set builder notation. All right, so 3 times -1 minus 5 times 2. So -3 minus 10 is -13. That means I know for my x that -13 is the denominator and y is -15. Now let's go find dx. It'd be 7 times -1 minus 5 times 4. So dx is -7 minus 20, or -27. dy would be 3 times 4 minus 7 times 2. So dy is 12 minus 14, or -2. That's the numerator of the y. For my final answer, since it was a system of equations problem, I'm just going to simplify the fractions. So when you divide two negatives, you get a positive answer. And that's all I can do for either one of these. Okay, so that's the big idea of what we have for Kramer's rule. So what I'm going to do next is I'm going to just repeat everything we've done, except I'm now going to go to a 3x3 matrix. So what you have right now at home is a decision to make of what you're going to be doing for your homework. So you can split this over 2 days and do all 2x2 stuff first for the book and the worksheet, or just the book, and then you can come and do the 3x3s, but just make sure you're pacing yourself to whatever you need to do. Personally, I would just finish the video, and then once I hit my 2 hours for the night, maybe stop and then start working early tomorrow before my class meeting. Okay, so a 3x3 matrix, we want to find its determinant. So we have to first set up something called cofactors in minor matrices, because we can find it of 2x2. So what we're really going to do is we're going to break this into like just a little tiny 2x2 matrix on the inside, and then we'll times a number out in front of it. So when we times that number out in front, that's a little cofactor that's going to help us come up with something called a cofactor. We either are going to add or we're going to subtract. If you add, you keep the sign. If you subtract, you add the opposite. So depending on the number that we're going to circle, so if I circle row 2, column 3, if I'm going to go look at this one right here, that means I'm going to change the sign of just that number. If I'm going to use row 2, column 2, I'm going to keep the sign of that number. Again, this is for just what we call the cofactor, and I'll explain that a little bit more in the next couple of slides. So what we're first going to do is find the minor of row 2, column 3. So what we're going to do is go to row 2, column 3, and we're going to circle that number. So you need to know how to read the elements. The row is first, the column is second. And then you're going to cover up that column and row. You're going to just not look at any of those numbers. Okay? And the other numbers that I did not circle or cover up, those are going to be my minor. So I got my 3, 2, 6, 8. And I'm going to find its determinant. So my minor determinant, 2, 3, would be 3 times 8 minus 2 times 6. So 24 minus 12 is 12. Now, if I want to find what we call the cofactor of row 2, column 3, I'm going to use the determinant I just came up with it there. And I'm going to decide, do I keep the sign or do I change the sign? So I call it the checkerboard of signs. So it always starts a positive in row 1, column 1, and then it alternates. So if we want this one right here, it's going to be a minus. So we're just using the opposite this time. So we have negative 12. We'll talk about how to use the 7 and the other 4 numbers later on to get the rest of the determinant of the 3 by 3. Okay, but we're going to have to figure out how to find a minor first and then figure out, do we want that sign or the opposite sign? Let's try this again. Row 3, column 1. So I cover up that row, cover up that row, and cover up that column. And then what I see left for the 4 numbers is my small little minor matrix. And I find my determinant just like we did in the first half of these notes. So we got negative 14 plus 20, so 6. And if you don't want to show that work, you don't have to. If you want to only show that work, that's perfectly fine. So now we're going to go find the minor for this. Well, we go to our checkerboard of signs. So we're looking for this spot right here. It goes plus, minus, plus. Well, that plus means keep the sign. So it's going to be equal to just the minor. So it's just 6. Okay, so now we're going to take this idea of finding minors, and we're going to use those to find the determinant of the entire 3 by 3. So whatever your dimension is, remember these are square matrices, so what a number of rows or the number of columns, that's how many minors you're going to have to use. So if I have a 3 by 3 matrix, I'm going to use 3 minors. And the minors will go down by 1 number, so I'm going to use 3 2 by 2 matrices. If you had a 4 by 4 matrix, you would have to make 4 3 by 3 matrices, and you'll use the same process. And then in that case, when you have a 3 by 3 matrix, then you have to break each one of those 4 3 by 3s down into 3 2 by 2s. So you just keep repeating the process until you get down to 2 by 2s, and then you can find determinants. Now, what we're going to do on the test is we are going to tell you a very specific row or a very specific column to use. So if all we see is the determinant, you're just going to get 1 of the 10 points. If you use the wrong row or wrong column, we're going to check your work, but you're going to lose probably at least half the credit. So a 5 out of 10 is not passing, okay, 50%. So you need to make sure you know what row or column you're going to expand it about. That's one of the ways we can test to see if you know this. We don't want to ask you such a low-level question as like, What's column 3? Okay, we're going to make you use column 3. So we are going to take column 3 right here. We're going to take that column, and that's what we're going to expand it about. Okay, so I'm going to go get a marker here, or highlighter, so we can see a little bit better. So we are going to use this column to expand. And the way we're going to expand is we're going to go row by row. So I'm going to expand it looking and covering up this first row. So when I cover up the row in the column, well, I'll see 4 numbers left over that are not highlighted. That makes my first minor. So I'm expanding, I'm going to get the minor for row 1, column 3. Okay, so I have 1, -4, 6, 8. But what we really want is not the minor, we want the cofactor. So I got to decide, do I keep the sign or do I change it? Well, from our checkerboard of signs, that third column would be keep the sign, change the sign, keep the sign, add, subtract, add. So I would want to keep the sign in the problem. Now there's one more thing we're going to do. That number you see highlighted in green, where the yellow and the blue come together, that number is going out in front. And if it's a plus, I keep the sign. If it's a minus, I change the sign. So this one, it's a plus in my checkerboard, I keep the sign. If you want to be mathematical about it, to know what sign or you should put in front there, whether it's +1 or -1, you would do -1 row plus column. So if the row and column are both odd or both even, that would add up to an even number, which would give you 1. We don't have to be that specific in a college algebra class, but if you move on to a linear algebra class, they would expect you to know that little rule. Okay, so now what I'm going to do is I'm going to move on to the next minor. So what I'm going to do, I'm going to expand all the way through column 3. So now I'm going to find the minor for row 2, column 3. Everything should have a column 3 in here. So in my checkerboard of signs, this is a minus, so I'm going to subtract this value here. I see that I have -7. So when we have that minus in there, we're going to use the opposite sign we see. And then I use the numbers that are not highlighted to make up my minor matrix. All right, one more to go. This is a 3x3 matrix. To find its determinant, I need 3 2x2 matrices. So in the checkerboard of signs, this is a plus. Add. It's +10, so I'm really going to add. Now, if this had been a -10, I would do plus -10 or just -10. And then the unhighlighted numbers make up my minor matrix. 3, 2, 1, -4. Okay, so we've done the expanding portion of this. I've expanded it correctly. So this is giving me about 30% of the credit at the moment here. Okay, now what I need to do is I need to evaluate each 2x2 matrix. So if you think about the order of operations, please excuse my dear Aunt Sally. Okay, parentheses or grouping symbols, the determinant must be done before you can multiply the 5. So this is not scalar multiplication because these are not brackets. You have to do the determinant first. So I have 5 times, and then I'm going to do 1 times 8. And then I'm going to subtract 6 times -4. And I have +7, 3 times 8, and then minus 2 times 6. And finally, plus 10 times 3 minus 4 minus 2 times 1. Go ahead and use brackets here so I can keep track of my order of operations a little bit better. Okay, at this point in time, if you want to type this entire thing in your calculator, be my guest. Okay, we're looking for like the calculator to do the basic stuff you knew before this course ever started. But I do need to see these 2 steps of work. Now, if you wanted to say 8 plus 24 instead, I can live with that. Or 24 minus 12, I can live with that. Okay, now we're going to go calculate. So 8 plus 24 is 32, or 160. And then we're going to add 7 times 24 minus 12. So 7 times 12 is 84. And finally, we got 10 times negative 12 minus 2, or negative 14. So minus 140. So 160 minus 140 is 20, plus 84 is 104. The things I put stars next to, you must show to earn full credit. It doesn't matter who your teacher is, Mr. Smith, Mrs. Perry, Mr. Henson. We will all take points off if we don't see these starred steps. Okay. The only option is, instead of these numbers, you could have an 8 plus 24, and that would be okay. All right. So the last thing we have here is solving a 3 by 3 using Kramer's rule. So we're going to do exactly what we did before. It's just, these are bigger matrices. So for our matrix equation, let's use our coefficients times our variables equals our constant. 2, 1, negative 1, and 1. 1, negative 1, negative 2, negative 8. And now we're going to set up a d, dx, dy, dz. So d would just be your coefficient matrix. And then you're going to do your dx. So I'm just going to copy this. But if I want to find dx, what I'm going to do is I'm just going to erase this x column, and I'm going to replace it with my constants. Make sure you copy it down correctly. A lot of people will lose a negative on one of their numbers, which completely throw off the answer. So then I'm going to find my dy next, and my dz. So when I want to find dy, I'm going to get rid of the y column. If I want to find dz, I'm going to get rid of my z column. And I'm going to replace those with the constants. And I can see those in my dx matrix, negative 1, negative 9, 1, negative 8. Now the next thing what I would have to do is I'd have to calculate each one of these. And then to solve for x, I would take my dx and put it over d. So when we say state the rule on the test, we are looking for this first fraction. Then I'm going to go get my numbers, and then I'm going to go simplify. And let me just set it up right here. This is what we would expect on the test. Now, we will have a problem where you have to find the determinant of a 3 by 3 matrix by hand and show the work like our previous example. When we get to the system problem, we're going to leave it like right here. And if you have this written down for that problem, you get 10 out of 10. Now, if you want to go use software or do this by hand, we'll give you some bonus points for it. So I'm going to show you how to use it in the graphing calculator to find the determinant of your 3 by 3. If you don't have a TI 84 or 83, or you don't have the Smart View, you can go Google and start looking for other software to find those if you want to. But I'm going to go find it right now. So let me put up my key press history so you can see what I'm typing in here. You're going to hit second x to the negative 1, which is matrix. You have to edit to get it in there. If you do not know your dimensions, you cannot use a calculator. So you have to know the dimensions. So these are 3 rows, 3 columns. Now it should have the same shape. And I'm going to put in matrix D first. And when you put it in, you go by row by row. So 1, enter. Now here's a watch out step. If you put in minus, it'll say error. You need to put a -2. You use the gray button here, it'll expect you to be subtracting 2 numbers and it doesn't see it, so it says syntax error. Okay, then I put in the next row 2, 1, -1. And the last row 1, -1, -2. You must quit. You must go back to the home page. Okay. Let me show the key press history. Sorry, I showed you the large screen last time. And then you're going to go through the quit, or else it'll try to put it inside the matrix and it gets all confused. So then the next thing we're going to do is we're going to go back to the matrix page. Now we're going to make it do the math. And that's choice number 1, determinant. For the third time, I'm going to go to the matrix page. I'm going to choose under names the matrix I saved, which was matrix 1. Close the parentheses, hit enter. So I came up with -12. That means in all my little fractions, I'm going to put a -12 in the denominator for D. Okay, so let me redo this now with the dx. Okay, so the dx is the same matrix I just had in there, except for the x column is going to be this -9, 1, -8. So you go second matrix, left arrow to edit, put in your dimensions, and then you type it row by row. Well, in this case, I don't need to redo all the typing. I just need to go change these. So I'm going to just type over. I'm going to push the down arrow to go the, if I push enter, it's going to go across row. I want to just change only that column. So I can use the arrow numbers, or arrows to go over the number I need to change. And now that I have it edited correctly, I'm going to quit. So second mode to go back to the home page. Then go to the matrix page for a third time. Arrow over, do the math. We're doing determinant, or number 1. Then we're going to go to the names, A. You could hit enter on A or just number 1 and hit enter. And now I'm going to get -54. All right. So -54 was my dx matrix. So I'm going to put that over here. So now I just have to just reduce this fraction. They're both multiples of 6, right? So I could divide that by -6 on the top and the bottom, or I can use the power of the graphing calculator, a scientific calculator, and just divide them. I'm going to hit math and put it as a fraction. Okay, so we're getting 9/2, or if you'd rather, 4.5. I'm going to leave everything as fractions. All right, I got the x coordinate. Now let's go find the y coordinate. So I'm going to go back to the matrix page, second, x to the -1, edit, and now I need to change the last 2 columns. So the last column really needs to be the -9, 1, -8. Okay, sorry, I made an error there. I actually typed in the dx, or the dy instead of dx. Let me fix that. I'm going to go get dz next, since I already started it. So I'm doing this one over here. And let me put in my -2, my 1, -1 back in here. And that's my dz matrix. Now I could go through the whole process again, but if I don't want to do all that typing, I just find where it says determinant of A and calculate it. So this is what, 7/6. All right, let's go back and find our last one so I can go back and actually get X this time. So I go to my calculator, second matrix, slide it over so I can actually see it this time. Let me edit matrix A, and still 3 by 3. And we rewrite it, -9. One has to go here. That's 1, 1, -1, -8, -1, -2. And it'll find the determinant, which is +14. So we put a +14 divided by a -12 will be a negative. It's still the same fraction as z, just opposite, -7/6. If this is all I do for my test, I get 9 out. I get all the bonus point but 1. I need to write the answer as an ordered solution. So again, when you get to this in your homework, we do expect you to solve on your homework. So you're either going to have to practice your 3 by 3s by hand, or you can go find a software, go Google it, see if you can find some. There's free software out there that will do matrices for you, or use the emulator, or use your graphing calculator if you own one. But you can go look for something, or you can practice by hand. On the test, again, you will have to do one by hand. Okay. All right. That's it for this unit. We will have a quiz tomorrow. Then we will have a review day, and then the test will be on the 8th.